of subject engineering maths. We were discussing chapter 4, that is complex variables, and in this session we discuss Cauchy's integral formula for derivatives, followed by classroom workbook based on Cauchy's integral formula and integral formula for derivatives. Now the concept is Cauchy's integral formula for derivatives. Cauchy's integral formula for derivatives. Now in the last session we have seen Cauchy's integral formula for normal functions. The formula will be like this: f of z naught equal to 1 by 2 pi I into integral f of z by z minus z naught dz over the contour C. Now this is the value of f of z naught. Here the power of z minus z naught is only 1. So in that case, integral f of z by z minus z naught dz over C is 2 pi I times f of z naught. Here the power of z minus z naught is 1 only. Now I can go for extension. Suppose if I have power n plus 1. So in this case, what is my integral value? Integral f of z by z minus z naught dz over C. This is equivalent to 2 pi I times f of z naught. So when I rearrange the terms, I will get like this. Now suppose if I have power as greater than 1, then how to get this formula? So therefore in this case the formula will be like this. Here it is 0 basically. Now it is nth derivative. Nth derivative of f at z naught equal to, here it is n factorial divided by 2 pi I into integral f of z by z minus z naught whole power n plus 1 dz or the contour C. So this is my formula. If I have power n plus 1, this becomes n factorial, this will be nth derivative. See, here n is written in the parenthesis. It represents we are finding nth order derivative of f at z naught is given by n factorial by 2 pi I into integral f of z by z minus z naught whole power n plus 1 dz over C. So when you rearrange the terms, my formula will be like this: integral f of z by z minus z naught whole power n plus 1 dz equal to 2 pi I by n factorial into nth derivative of f at z naught. Of course, if z naught lies inside the contour C, so this will be 0, that is integral f of z by z minus z naught whole power n plus 1 dz over the contour C is 0 if z naught lies outside C. If z naught lies outside C. So therefore we have these two formulae for derivatives. So write this formula. First you start with this Cauchy's integral formula for higher derivatives, and then you write this formula followed by this followed by this and this. Highlight all the formulae. We start classroom workbook from question number 36. Go through question number 36. The value of the integral in the complex plane. This is what? Integral z cube minus 2z plus 3 divided by z minus 2 dz along the contour mod z equal to 3 taken counterclockwise is. So we need to find out this contour integral where the direction of the contour is counterclockwise. So by default it is counterclockwise direction only. Now let us evaluate this. Now numerator is a polynomial expression. So here what is f of z? Z cube minus 2z plus 3. Now it is analytic at all points inside and on the boundary of this circle. Now here z naught equal to 2. So this point lies inside this circle, mod z equal to 3. Therefore by Cauchy's integral formula, this will be equal to 2 pi I into f of z naught. So this is 2 pi I into, so f of z naught value, let us calculate here. So f of z naught, that is f of 2. So 2 cube minus 2 into 2 plus 3. So this is 8 plus 3, 11 minus 4, this is 7. So therefore this is 2 pi I into 7 and this is 14 pi I. So it's a very straightforward question. Apply integral formula, directly you get the result. Just matter of 10 to 20 seconds, not more than that. So option C is right answer. Next question, 37. Let Z be a complex variable for a counterclockwise integration around a unit circle C centered at origin. So what is the contour? The contour C is described by mod Z equal to 1. Unit circle means radius is 1, centered at origin. Therefore, it is given by mod Z equal to 1. And it is given like this. Integral 1 by 5z minus 4 dz over C equal to a pi I. A pi I. Then what is the value of A? So options are given like this. Directly this contour integral is given as A times pi I, where A is some constant. We need to find the value of A. Now this must be in the form integral f of z by z minus z naught. Now let us see, this is 1 by 5 into, you take 5 common, 1 by 5 into z minus 4 by 5 dz over mod z equal to 1. So therefore this is this is equal to 1 by 5 divided by z minus 4 by 5 dz over mod z equal to 1. Now this is f of z. So what is f of z? F of z equal to the constant function 1 by 5. What is z naught? Here z naught is 4 by 5. So this is basically 0.8. Now you can see modulus of 0.8 is 0.8, 0.8 less than 1. So this point lies inside the circle. So this lies inside the contour, that is mod z equal to 1. Therefore, by Cauchy's integral formula, this will be equal to 2 pi I into f of z naught. But this is a constant function, so f of z naught is also equal to 1 by 5. So therefore, this is 2 pi I into 1 by 5. So therefore, this is 2 by 5 into pi I. Therefore, in place of A, we have 2 by 5. Therefore, the constant A is nothing but 2 by 5. 2 by 5. So option A is right answer for question number 37. Note this. Using the Cauchy's integral theorem, the value of the integral, even direction is mentioned as counterclockwise. It is like this. Integral 8 minus 7z divided by z minus 4 dz around the circle with the center 0 and radius 8. That means the circle is like this, mod z equal to 8 is options are given. Now here what is f of z? F of z is a numerator function, that is 8 minus 7z. This is z naught equal to 4. Now mod 4 equal to 4, but 4 less than 8. Therefore here z naught equal to 4 lies inside this circle, mod z equal to 8. Therefore by Cauchy's integral formula, this contour integral, that is integral 8 minus 7z by z minus 4 dz over mod z equal to 8. This will be equal to 2 pi I into f of 4 because z naught is 4. Therefore this is 2 pi I into f of 4, 8 minus 7 fourths. So therefore this is 2 pi I into this is minus 20, therefore this is minus 40 pi I. So minus 40 pi I, option C is the right answer. But even 40 pi I is there in the option, that is D. That will be true if the direction of the contour is clockwise direction. Clockwise direction means original value with minus sign. Otherwise you can take direct value. So then they mentioned very clearly anti-clockwise. Even if the direction of the contour is not specified, take it anti-clockwise. If they mention, take anti-clockwise. But if they specify clockwise, do the original value by using Cauchy's formula and then add minus sign extra. So in this case it is minus 40 pi I. Option number C. Note this. We move to question number 39. The values of the integral 1 by 2 pi I into integral e power z by z minus 2 along a closed contour C in the anti-clock direction for point number 1, the point z naught equal to 2 inside C, and second one, the point z naught equal to 2 outside C. Respectively R. So here contour C is not given. See why contour C is required for us to say whether the point z naught is an interior point or an exterior point. If it lies inside, it contributes some value. If it lies outside the circle, the value is 0. So therefore here contour is not given, but the clues are very given. So we need to know whether z naught lies inside the circle or not. So in case 1, the point z naught 2 lies inside the circle. In second case, z naught equal to 2 lie outside the circle. So in that case, what are those values? I will get one value for this and one value for this. In case of 2, the contour integral is 0. Right? Now you can see. In the first case, actually this is 1 by 2 pi I. I was discussing point number 1, case 1. So 1 by 2 pi I into integral e power z by z minus 2 dz over C. Suppose if 2 lies inside the circle, this will be equal to f of 2 because z naught is 2 and this is my f of z. What is f of z? E power z. So this is e square. Now the value of e square is 7.39 because the value of e is 2.71 Euler's constant. Now in case 2, 1 by 2 pi I times integral e power z by z minus 2 dz over C. This becomes 0 because 2 lies outside the circle. So therefore in case of 1, the value is 7.3. In case of case 2, it is 0. So 7.390. So the option B is right answer. The value of integral z square minus z plus 4i divided by z plus 2i dz over the curve mod z equal to 3. Is, so numerator is z square minus z plus 4i, denominator is z plus 2i, curve is mod z equal to 3. Now let us identify what is f of z, what is z naught, what is contour. Now here f of z is a numerator function. This is z square minus z plus 4i. Now this is anyhow polynomial expression, no issues about its analytic properties. Now here z naught is minus 2i, because this is in the form z minus of minus 2i, so z naught becomes minus 2i. Contour C is given like this, mod z equal to 3. Now you can see modulus of minus 2i. This is 2 only, so this is less than 3. Therefore, z naught equal to minus 2i lies inside the contour mod z equal to 3. Therefore, by Cauchy's integral formula, this contour integral, that is integral z square minus z plus 4i divided by z plus 2i dz over mod z equal to 3 is given by 2 pi I into f of minus 2i. Now let us calculate what is f of minus 2i. So here f of minus 2i is, this is minus 2i whole square minus of minus 2i plus 4i. Here I square is minus 1. So therefore this is minus 4 plus 2i plus 4i. So the result is minus 4 plus 6i. Therefore when you go for this integral, this will be equal to 2 pi I into minus 4 plus 6i. Now let us see what is right option. Okay, here I is distributed to this expression. So this is basically minus 8 pi I plus I into I square. So therefore this is minus 12 pi. Now let us go through option A. In option A plus 12 pi, but in option B minus 12 pi minus 8 pi. So therefore option B is right answer. Option B is right answer, not this. Question number 41. The value of integral e power 2z divided by z plus 1 whole power 4, where C is the circle defined by mod z equal to 3. So we need to find out this contour integral. Now here the power is not 1, it is 4. Therefore we need to apply integral formula for derivatives. So what is f of z value? F of z value is e power 2z. Now what is z naught? It is minus 1. Here n plus 1 is 4. Therefore the value of n is 3. Now this is anyhow, so here we need to differentiate this function with respect to z 3 times. Anyhow this minus 1 belongs to this circle. So z naught is minus 1. Modulus of minus 1 is 1, 1 less than 3. So minus 1 lies inside the circle mod z equal to 3. So here f of z is e power 2z. Differentiate this with respect to z 3 times. So the first derivative of e power z is 2 times e power 2z. Second derivative is 4 times e power 2z. Third derivative is given by 8 times e power 2z. Therefore, third derivative of f at z naught is given by third derivative of f. Here z naught is minus 1. Therefore, you will get 8 times e power minus 2. 8 times e power minus 2. Therefore, this integral is integral e power 2z by z plus 1 whole power 4 dz over mod z equal to 3 is given by 2 pi I divided by n factorial. Here n value is 3. So 3 factorial into third derivative of f at minus 1. So this is 2 pi I divided by 3 factorial is 6. Third derivative of f at minus 1 is 8 times e power minus 2. Now cancel 2 4 times and 3 times. So 8 pi I by 3 times e power minus 2. 8 pi I by 3 times e power minus 2. So option A is right answer. Note this. The value of integral sin z by z minus pi whole square dz over mod z equal to 2 pi, where the curve is taken in anti-clockwise. So here direction of the contour is anti-clockwise. Now here what is f of z? Numerator function, this is sin z. Here n plus 1 equal to 2. N plus 1 value 2, therefore n value is 1. Now here z0 is pi. The contour is mod z equal to 2 pi. So replace z by z0. So pi, this is pi less than 2 pi. Therefore pi lies inside the contour. Pi lies inside the contour mod z equal to 2 pi. Therefore, since we are applying Cauchy's integral formula for derivatives, here the power is to differentiate this with respect to z one time. So here f dash of z0. Basically f dash of z0 is cos z0. But what is z0 value? This is pi. So therefore this is cos pi. So what is cos pi? Cos pi is minus 1. Cos 180 degrees is minus 1. Therefore, in this case, the value becomes this integral, that is integral sin z by z minus pi whole square dz over mod z equal to 2 pi. This becomes 2 pi I by 1 factorial into f dash of z0. So 2 pi I into f dash of z0 is minus 1. Therefore, the answer is minus 2 pi I. Minus 2 pi I. So option A is right answer. Question number 43. The integral z cube into e power z divided by z cube into e power z by z minus 1 whole cube dz along the curve C. The curve C is described like this: mod z equal to pi by 2. Oriented along clockwise is. Now let us calculate this. Here what is f of z? Z cube into e power z. Now this is analytic function, this is analytic. Analytic means they are differentiable functions. So ultimately product of two differentiable functions is differentiable. Now here my contour is mod z equal to pi by 2. Here z0 value is 1. The contour is mod z equal to pi by 2. Basically this pi by 2 is nothing but 1.57. Replace z by 1. Modulus of 1 is 1. This 1 less than 1.57. Therefore this z0 lies inside the circle mod z equal to pi by 2. Now anyhow direction of the contour is anti-clockwise direction. So here n plus 1 value is 3. So n value is 2. Therefore, we should differentiate this numerator function 2 times. So first, let us find the first derivative f dash of z. So apply product rule: z cube into e power z derivative e power z plus e power z into derivative of z cube is 3z square. Now let us go for second derivative. So instead of so directly I can write like this. This is e power z, you can take common. So this is z cube plus this is 3z square. Now apply second derivative f double dash z. This is u, this is v. Product rule: e power z into derivative of this 3z square plus 6z plus z cube plus 3z square into derivative of e power z is e power z. But here z0 is 1. So f double dash of z0, this is nothing but f double dash of 1. So replace z by 1. This is e times 3 plus 6. This is 9 plus 1 plus 3, 4. So this is 4e. So this is nothing but 13 times e. Therefore, by Cauchy's integral formula for derivatives, this integral becomes integral z cube into e power z by z minus 1 whole cube dz over mod z equal to pi by 2. This is given by 2 pi I by 2 factorial into second derivative of f at z0. Now 2 factorial and 2 gets cancelled. This is pi I into this second derivative of f at z0 is 13e. So therefore the value is 13e pi I. So option C is right answer. 44. Using Cauchy's integral theorem, the value of integral taken in counterclockwise direction. The integral is integral z cube minus 6 by 3z minus I dz over mod z equal to 1. Now let us evaluate this. So here you can take 3 common. This integral is 1 by 3 times integral z cube minus 6 by z minus I by 3 dz over the circle mod z equal to 1. Here f of z equal to z cube minus 6 and z naught is I by 3. Modulus of I by 3 is 1 by 3 and 1 by 3 less than 1. So this lies inside the contour C. This is my contour C. Therefore, by Cauchy's integral formula, this becomes 1 by 3 into 2 pi I into f of I by 3. So, therefore, this is 2 pi I by 3 into f of I by 3. So, this is I by 3 whole cube minus 6. So, therefore, this is 2 pi I by 3 into I cube means minus I by 27 minus 6. So, therefore, I into I square is minus 1, already plus 1 is there. So, therefore, this is 2 pi by 81 minus, this is 3 to 4 pi I. 2 pi by 81 minus 4 pi I. So, therefore, option A is right answer for question number 44. Note this.